The 777X was supposed to bury the Airbus A350. Instead, it buried Boeing's credibility, several billion dollars, and the careers of executives who never saw it coming. What makes this crazy is that it did not have to go this way. Boeing had already built one of the greatest commercial aircraft in history. The original 777 is still every airline's dream. All they had to do was upgrade it. New wings, new engines, same dominant platform. And somehow, they bricked it. So, how does a billion-dollar company fumble such an easy layup the day the sky started throwing punches? It's December 8, 2020. A brand new 777-9 is somewhere above the Pacific Northwest, and everything looks clean. Boeing's test pilots are methodically burning through their checklist. The kind of flight that should generate nothing but yawns and data logs. Then, without a single input from the crew, the nose pitches up, then violently down. The aircraft is doing something it was never told to do, and nobody in that cockpit asked for it. For Boeing, this wasn't just a bad day at the office. This was their flagship comeback jet, the aircraft that was supposed to tell the world Boeing still knew how to build planes, doing exactly what had killed 346 people across two 737 MAX crashes the year before. An uncommanded control event. The FAA, now operating in full distrust mode after the MAX catastrophe, immediately flagged it. By June 2021, the agency sent Boeing a pointed formal letter stating the 777X was not ready for type inspection authorization, a critical certification milestone, and demanded a complete technical explanation for the pitch event. Boeing, embarrassingly, could not fully provide one. The program, that was supposed to be the company's redemption arc, had just added another chapter to the same nightmare it was trying to escape. But to really understand the depth of this failure, you need to rewind to when Boeing was genuinely untouchable. When Boeing was cooking, the original 777 program launched in 1990, and what followed was one of the most impressive engineering achievements in commercial aviation history. Boeing took the entire thing, from blank page to passengers boarding, in just over 5 years. The plane was designed entirely on computers, the first commercial aircraft ever built that way, which eliminated physical mock-ups and cut development time dramatically. Boeing also did something unusual for the era. It invited airline customers into the actual design process. Not focus groups, not surveys, genuine engineering input. Cathay Pacific's feedback literally changed the fuselage diameter, which gave the cabin that signature wide feel passengers still notice today. The 777-300ER became so capable that airlines started parking their 747 setters permanently and running the twin-engine 777 on routes that once required a 4-engine jumbo. That is not an upgrade. That is a hostile takeover of a market segment. The 300ER was Boeing operating with total aura, and it sold so well for so long that it genuinely felt like the product could last forever. Which is exactly the kind of thinking that gets you into trouble when a competitor shows up with something new, thrown under the Airbus. The A350-1000 was not necessarily the most revolutionary aircraft ever assembled, but Airbus did not need it to be. They positioned it with surgical precision as a direct threat to the 777-300ER, promising better fuel burn, lower maintenance overhead, and the natural appeal of a newer design. Airlines that had been loyal Boeing customers for decades started taking meetings in Toulouse. For Boeing, the urgency was real, and the timing was absolutely brutal. The early 2010s were genuinely chaotic inside Boeing. The 787 Dreamliner had just survived a worldwide fleet grounding after lithium battery fires. The 737 MAX had just been announced as a panicked counter to the A320neo, and the stretched 787-10 variant was pulling on engineering resources from yet another direction. Rather than develop a completely new aircraft, which would have been the right long-term answer but a completely impossible short-term one, Boeing chose to upgrade the existing 777 platform. New composite wings, folding wingtips, General Electric's brand new GE9X engines. Target entry into service 2020. Emirates and Lufthansa signed on as launch customers in September 2013. Over 300 aircraft sold before a prototype had flown. To Boeing's credit, the engineering ambition behind the 777X was real. The new composite wing, built in a brand new billion-dollar facility in Everett, Washington, was one of the largest single composite structures ever manufactured for a commercial aircraft. The folding wingtip mechanism, which drops 7 feet of each wingtip down on the ground to keep the plane within standard gate limits, required its own certification process. Boeing was not being lazy. They were being optimistic, which in aerospace is arguably more dangerous. Boeing called it a straightforward upgrade of a proven design. That sentence would age very badly. The robot that 8 years of development. One of the more painful subplots buried inside the 777X story is the robot situation. Boeing launched an initiative in 2015 called FORB, Fuselage Automated Upright Build. The concept was genuinely compelling. Instead of workers installing millions of rivets by hand, robotic systems would handle the process faster, cleaner, and cheaper. Boeing invested heavily and sold the idea internally as a manufacturing revolution. It did not work. The robots produced more defects than they eliminated. The workers Boeing intended to replace ended up spending enormous hours correcting what the machines got wrong. Instead of accelerating production, FAUB created a new manual workload on top of the existing one. Boeing initially dismissed the problems as early-stage teething issues and kept pushing. But months became years, the fundamental flaws persisted, and by late 2019, Boeing scrapped the entire FAUB concept and quietly went back to largely manual assembly. Years of development time, hundreds of millions in investment, gone, and the fuselage still got built by hand. For an aircraft program that was already running behind schedule entering that year, this was not a small blow. The plane that exploded in a lab? If the robot failure was an expensive embarrassment, what happened in September 2019 was something else. A 777X fuselage was undergoing static load testing, a standard certification procedure where the airframe gets pressurized and physically loaded to simulate the harshest stresses of real flight. Certification requires the structure to survive 150% of its maximum designed load limit. The 777X fuselage failed at 148%. It ruptured in a test facility. Photos leaked immediately. The aviation press went into a full feeding frenzy. The framing was brutal. Boeing had a fundamental structural failure on its supposed comeback aircraft. The engineering reality was actually more nuanced. A 2% shortfall in ultimate load testing is a margin deficiency, not a catastrophic design collapse. You reinforce the structure, retest, move on. Plenty of aircraft programs have encountered similar issues and resolved them without lasting consequence. But context is everything. The 737 MAX was still grounded. The FAA was operating with zero tolerance for Boeing ambiguity. Regulators worldwide, EASA, chief among them, had stopped automatically rubber stamping FAA certifications and were now running fully independent evaluations. Every Boeing problem was now pure public dopamine for a press that had been burned by the MAX story. There was no quiet fix available anymore. When the regulator stopped playing nice, the uncommanded pitch event in December 2020 broke something that was already cracked. The FAA's posture toward Boeing had fundamentally changed after the MAX crashes, and the 777X kept providing new reasons for that posture to harden. The agency had previously delegated substantial certification authority to Boeing's own engineers, allowing the manufacturer to essentially validate its own work. After 346 deaths, that arrangement was finished. FAA personnel now needed to be physically present at Boeing facilities, watching tests in real time, reviewing raw data, and signing off on processes themselves. This is not inherently a bad system. It is actually a better system. But it is a dramatically slower one, and it arrived at Boeing exactly when the company could least afford slower. Making things worse, Boeing's leadership made a decision during this period that cost the 777X program months it had no business losing. With the 737 MAX 7 and MAX 10 still buried in their own certification struggles, Boeing redirected engineering resources away from the 777X to tackle the MAX backlog. The 777X program stalled while key engineers were pulled to fight a different fire. For an aircraft already years past its promised entry into service date, this was the equivalent of deciding to rearrange deck chairs. Hawaii absolutely destroys the vibe. Boeing finally received type inspection authorization from the FAA in July 2024, roughly 4.5 years after the 777-9's first flight in January 2020. This was a genuine milestone. FAA pilots could now begin their own certification flights, the last major hurdle before deliveries could begin. For about 6 weeks, things actually looked like they might be trending toward normal. Then on August 15, 2024, a test aircraft landed at Kona International Airport in Hawaii after 5.5 hours of evaluation. Routine post-flight inspection. One of the engine thrust links had cracked. A thrust link is a titanium structural component that connects the engine to the wing pylon and routes all of that engine's thrust forces into the airframe. The GE9X engines on the 777X produce around 110,000 pounds of thrust each at takeoff. For context, that engine's cowling diameter is wider than the fuselage of a 737. The forces being transmitted through those thrust links are extraordinary, and when one cracked, Boeing grounded every 777X test aircraft and started inspecting the fleet. What they found was cracks across multiple aircraft, not a single bad part, a pattern, a systemic design issue. And because Boeing designed the thrust link structure even though GE manufactures the engines, the engineering responsibility lived entirely in Everett, Washington. The program, again, stopped. Still not done. Obviously, Boeing worked through the thrust link problem, redesigned the components, revised the inspection approach, and resumed testing. Then in January 2026, Boeing and General Electric identified a new durability problem inside the GE9X engine itself during routine inspections. The full details remain undisclosed. The consequence is not. First delivery, which had been targeting the back half of 2025, is now officially pushed to mid-2027. Several analysts believe even that is generous. Do the full accounting. The original 777 went from program launch to commercial service in just over 5 years. The 777X was announced in 2013. In 2026, 13 years later, no airline has taken delivery of one. Emirates committed to 150 aircraft, the largest single wide-body order in history at that point, worth somewhere north of $50 billion at list price. Lufthansa, Qatar Airways, and a handful of others are sitting in the same holding pattern. These airlines built entire fleet retirement schedules and route strategies around an aircraft that keeps moving toward the horizon. Between 2019 and 2023, Boeing accumulated losses exceeding $30 billion. A machinist's strike in late 2024 added further disruption to production momentum at exactly the wrong time. The institutional knowledge erosion from years of layoffs, buyouts, and internal restructuring is the kind of damage that does not appear on a balance sheet but absolutely shows up in engineering quality. The 777X has the longest wingspan of any commercial aircraft ever built, 235 feet, nearly 72 meters. The folding wingtip system exists specifically because without it, the plane would push into a gate category that most airports cannot accommodate. Boeing solved that specific problem with genuinely clever engineering. What they could not solve was the organizational decay that turned a supposedly straightforward derivative upgrade into a 13-year odyssey with no confirmed end. The original 777 was built by a company that invited its customers into the design room, listened to what they said, and delivered ahead of where the industry expected. The 777X is being built by a company that has spent over a decade trying to outrun a competitor, a regulator, a workforce crisis, and its own past mistakes simultaneously. One of those two versions of Boeing knew exactly what it was doing. The other one is still figuring it out.